So in this video, we're going to work through an example of differentiating a function that involves an inverse sine. So it says find the derivative of f of x equals the arc sine of x plus x times the square root of 1 minus x squared. So this is actually in some sense a simpler example than the previous ones, but there is some simplification that's required, and so that takes a little bit of algebra, and that's why this particular example has been included. So the derivative of the arc sine is going to be very straightforward in this case. We just go straight to the formula that was developed for it in video 1. So we're going to get 1 over the square root of 1 minus x squared, or 1 minus x squared all to the half power, plus, now we have a derivative that we've seen before. We know that we need to use the product rule because I have a product of two functions. Chain rule because there's a function composition going on. So we'll just go ahead and attack this. The product rule says take the derivative of the first function, which is 1, and multiply it by the second function, which is the square root function. So 1 minus x squared to the 1/2. Plus, then the chain rule says take the first function x and multiply it by the derivative of the second function. So I'm going to take the derivative of 1 minus x squared to the half. So first we work with the outer function and we bring the exponent down. So we get 1/2, 1 minus x squared. We subtract 1 from the exponent to get negative 1/2. Times, and then we have to multiply using the chain rule by the derivative of the inside function. The derivative of the inside function is negative 2x. And then we want to start simplifying things as much as we can. So here we have a 1 over the square root of 1 minus x squared sitting right here, plus, and now I have a square root of 1 minus x squared sitting here, plus, and right here the half will cancel with the 2, so it looks like we're going to get a negative x times x is negative x squared in the numerator over, and it's going to be over a square root. So I have the minus, the negative exponent here means I can tuck that square root down into the denominator, and we'll get 1 minus x squared in the denominator. So here's what I've got going on. So here I've actually got the same denominator on these two. So that can be combined using a common denominator. So I'm going to get 1 minus x squared in the numerator all over the denominator, which is 1 minus x squared. And I have plus the square root of 1 minus x squared sitting here. And we're going to go ahead and get a common denominator for this term so we can combine things. So I'm going to go times, and we're going to multiply by square root of 1 minus x squared over the square root of 1 minus x squared so that it's equivalent to 1. When we do that, we're going to get a denominator of the square root of 1 minus x squared, and then it's going to be the first numerator, which is 1 minus x squared, plus the other numerator, and I have the square root times the square root. The square roots are going to cancel because I'm going to wind up with 1 minus x squared squared, and the squaring will cancel the square root, and that'll leave me with 1 minus an x squared sitting here. And then we can combine these. There's 2 of them, so this is 2 of the 1 minus x squareds over, and this is the square root of 1 minus x squared, and this is going to equal 2 times just the square root of 1 minus x squared when we simplify it. So that's going to be the final simplified derivative. And to see why that is the case, so you can turn the video off if you're happy with that right now, but to see why this is the case, let's just look at 1 minus x squared over the square root of 1 minus x squared. And I'm going to write it with a 1/2, and I'll write this upper exponent as a 1. So we're really simplifying this when we're simplifying this piece right over here. So we want to recognize we have the same base. And when we have the same base, you take the upper exponent and you subtract the lower exponent is one way to think about it. There's other ways to think about this as well, but this is probably the simplest way to think about it. And that's going to give you 1 minus x squared, and 1 minus a half is just a half, or 1 minus x squared under the radical sign. So that's how we simplified that piece.